Good morning, students. Today I am going to start the Unit 1. Unit 1 is Power Semiconductor Devices. So, in our yesterday's class, I discussed about what is power electronics and why we are using these power electronics devices. So, the main purpose of this power electronics is to control the power. So, how we control this power? This is the main question. How we control the power? How we control the power means by using the switching operations. Okay, now so here we are going to use some switching devices like thyristors and diodes and transistors. These are the some of the switching devices generally we are using in power electronics. Okay, now so let us see what are the different types of power electronic devices. So generally these power electronic devices are three types. Those are, first one is power diodes, and second one is transistors, and third one is SCRs. So let us see how these three are. So here the power semiconductor devices are categorized into three types. So those are power devices, transistors and thyristors. If you see here, generally these power diodes are used up to the range 600 volts to 4500 amperes only. And second one is transistors. So there are different types of transistors is available. So each and every transistor works on the same concept, but there is a different variation of range is existed for utilization purpose. So, and third one is thyristors. Thyristors is also called as a SCRs, silicon controlled rectifiers. So these are the generalized power semiconductor devices, and these internally divided into so many types. For suppose if you take the diodes, there are so many different types of diodes is there. Shackle diode, for example, shackle diode, Zener diode. Likewise, there are so many types of diodes is existed. Similarly, if you take the transistors also, there are so many transistors are existed. So it depends upon our requirement, we can use different types of transistors. And today we are going to discuss about these thyristors, and our entire power electronics is also mainly based on this thyristor or SCR. Okay, na? So before going to the thyristor, let us see the basic operation of the diode. Why? Because by using this basic operation of the diode only, we are going to operate the SCR also. Okay, na? So let us see the basic operation of the diode. Basic operation means generally this diode is works on two types. That means forward bias and reverse bias. So let us see how the diode is forward bias and reverse bias. So if you see here, this is the reverse bias connection for a diode. So how can we connect this in reverse connection? Means n-type region is connected with positive and negative is connected to the p region of the diode. With this connection, we see this here in n region all are negatives, and these all are try to flows towards positive region, that means plus side, and in P region all these are positives and it is connected to the negative terminal, so all these are attracted to the negative region. So because of this connection, this is the depletion region, and this depletion region is going to be increased. Okay na? So because of the increasing of the depletion region, there is a no flow of electrons from N region to P region. So indirectly there is no flow of electrons is possible in reverse bias connection. So if you increase the voltage beyond the certain limits, after certain limits this diode gets damaged and there is no working for diode. So in reverse bias connection there is no flow of electrons is existed. Okay na? Next see the forward bias. So how the forward bias is connected means it is shown in figure below. That means negative terminal is connected to the negative side N region and positive terminal is connected to the P region. If you observe one thing here, this is positive and this is also positive, these two are gets repelled. Okay na? So for that purpose these all positives are reaches to the N region. That means here in P region there contains all holes. These holes are flows towards the N region. Similarly, if you see this N type, N region is connected to the negative side. Here also this is negative and it is connected to the negative side. So because these two are negative, these two gets repelled, and what are the electrons existed here, that all are flows through the P region. So indirectly because of this type of connection, this depletion region is going to be closed. Okay na? That means vanished. There is no existence of depletion region in between the P type material and N type material. So if there is no depletion region means there is a flow of electrons from N region to P region or P region to N region. So indirectly depletion region is vanished means indirectly there is a flow of electrons is existed in the diode. That means if you connected the diode is in forward direction, it acts like a closed switch. That means it passes the current from one side to another side. If you connect the diode in reverse direction, that means in reverse bias condition, it acts like a open switch. That means there is no flow of electrons from one region to another region. Why we are going to transistors, even though we are having the diodes, but why we are going for the transistor means there is no control. That means if you use the diodes, there is no on and off condition for the diode. For that purpose we are going to the transistors. Okay na? Let us see the structure of the SCR. So this SCR is the very important for the power electronics subject. Why? Because our entire discussion, that our entire topics are based on this SCR only. So let us see the construction of the SCR. So how the SCR is constructed means, SCR is a 4-layer structure and it having the junctions, 3 junctions, J1, J2, J3. This is J1, this is J2, this is J3. So indirectly we can explain that SCR is a 4-layer device having the 3 junctions. These 4 layers are 2 is p-type regions and 2 is n-type regions. These p-type and n-type regions are arranged alternatively as shown in figure like this. So this is the basic structure of the SCR, and the symbol of the SCR is this one. So this P is called anode and this N is called cathode, and here at P there is a gate pulse or gate is existed in the SCR for controlling of the on and off of the SCR. Okay na? So this is the basic structure of SCR. We can design SCR by using transistors also. For example, by using 2 transistors we can design one SCR. See here, this how we can design SCR by using 2 transistors. This is the PNP transistor and this is the NPN transistors. So if combination of these 2 we can get the SCR. Okay na? So let us see here, this N and N are connected in common and these P and P are connected in common, and there is a gate is connected for the P region. Indirectly we can conclude that by using 2 SCRs we can design by using 2 transistors we can design a one SCR. This is the physical structure of 2 transistors connected. Okay na? So if we connected 2 transistors like this we get the SCR, and finally we are getting the SCR like this PN structure. Okay na? Here we are going to apply the gate for controlling of the SCR. This is the basic structure of the SCR. Okay na? So student, here you have to remember one thing. This thyristor is also called as a SCR. Okay na? Sometimes we use the name as a thyristor, sometimes we use that as a SCR. Both SCR and thyristors are same. SCR is the another name of the thyristor. Okay na? So this is about the basic construction of the SCR. So let us once again see how this SCR is constructed. So how can we define SCR? Means SCR is a 4-layer 3-junctioned device. Here 4 layers are 2 p-type regions and 2 n-type regions. These p and n-type regions are connected alternatively, and a gate is also existed at p-type region. Why we are using this p-type region? Means for controlling of the SCR or for on and off of the SCR. In our next class we will discuss how this SCR is going to be on and off. Okay na? So okay students, in our next class we discuss about what is the function of SCR and how the basic operations of the SCR. ఓకేనా. సో ఇన్ అవర్ టుమారోస్ క్లాస్ we see these two topics. What are those? What is the basic operation of the SCR? Okay na? Okay, thank you.